Ideal gas law, calculations. Quite often, one of the variables we use to describe a gas changes because of a chemical reaction or some environmental change. We can use the gas laws to calculate the new value for the variable. We have a process here. First, write out the givens and the unknown. That's pretty standard for all physics problems. 2, write the ideal gas law for the initial and final states and divide them to cancel terms that are the same in both states. Write a new expression with just the variables of interest. 3, solve for the unknown. And then 4, substitute the known values to find the unknown. Let's work an example. A sealed 13 milliliter balloon at 34 degrees Celsius is heated to 78 degrees Celsius at a constant pressure. What is the new volume of the balloon? Step 1, write out the givens and the unknown. Here's our givens. And notice, please don't use Celsius. Add 273 to Celsius to get Kelvin. We always use Kelvin with the ideal gas law. Write the ideal gas law for the initial and final states. So it's P1V1 equals N1RT1 divided by P2V2 equals N2RT2. Yes, you can do that with simultaneous equations where both of them have to be true. We cancel out like terms. Those are the terms that are the same in both states. Then write a new expression with just the variables of interest. This is all that survived the canceling out here. Solve for the unknown, and the unknown is V2. So we cross multiply, we get V1T2 equals V2T1. Divide through by T1, and we now have V2 isolated on the left side. And finally, at the very end, substitute in our variables and our givens there. Kelvin goes out. We're left with 14.4 milliliters. A rigid 18.5 liter gas canister. Now, what does that mean? What's going to stay constant here? Volume. It has a temperature of 13 degrees Celsius when the pressure gauge reads 45 atmospheres. At what temperature will the pressure decrease to 30 atmosphere? Here's our givens. We have the initial pressure and the final pressure, and we have the initial temperature, which is 13 Celsius, but we add 273 to get Kelvin. The volume is constant. We have a rigid container, so it will cancel out, as seen below, right down here. So we write the ideal gas law for the initial and final states and divide the two equations to cancel the terms that are the same in both states. So the constant R is the same. Number of moles is the same, volume is the same, so we're left with P1 over P2 equals T1 over T2. We want to find the final temperature, so we need to solve for T2. So we cross multiply, we get P1 T2 equals P2 times T1. Divide both sides by P1, and here's our final expression for T2. Substitute in our givens. The atmospheres will cancel out. Do the math, and we have 190 Kelvin.